This is 5-Minute Friday on 5 hacks for data scientists by using the ChatGPT Code Interpreter. Welcome back to the Super Data Science Podcast. I'm your host, Jon Krohn. For today's episode, I'm going to take you through a tour of the ChatGPT Code Interpreter. And I am, most of our listeners of the show listen in an audio-only format, so I will be narrating everything effectively. But if you want to, you can also check out the YouTube version of today's episode where I've got a screen share of everything that I'm talking about that will, if you have any doubts about what I was describing to you in an audio-only format, you've got that video option as well. There are some really crazy things that I'm going to show you with this code interpreter if you haven't used it before. So how does the code interpreter work? So you have to have a ChatGPT Plus subscription, which I personally do and I highly recommend because you can use GPT-4 and save lots of time on all kinds of tasks. And especially tasks involving code and tasks involving data science analyses, as you're going to see in today's episode or hear about in today's episode. So if you haven't used the code interpreter before, the first thing that you're going to have to do is go down to where your email address is in the bottom left-hand corner of the screen, click on Settings and Beta, and then go to the Beta Features section of Settings and turn on the code interpreter. So there's just a little toggle for you to do that. It's pretty straightforward, pretty intuitive. You can create a new chat and then make sure you select the GPT-4 model, and there's like a drop-down menu there. You can choose just the default GPT-4, which is super powerful on its own. You can choose to have plugins, which is kind of a separate thing. You can have like Wolfram Alpha there to do math for you, for example, or you can do internet searches with those plugins. Today we're focused on the code interpreter. So you select the code interpreter option from the GPT-4 drop-down menu. In the interest of time, I've got a chat that I've already run, which is, so we don't have to sit here while all of my code runs. What I did as an example is I found on GitHub, I found a raw file of this Boston housing data set, which is a famous data set for teaching examples of machine learning. It's got house prices from, I think, the 1970s in Boston. And there's about 500 different regions, so 500 rows of data. And for each of those rows of data, there's a bunch of variables. So one of those variables is the median value of houses in that region. And then there's a bunch of other variables that you can use to predict house price. So you can easily find an example raw kind of CSV file like this online, and you can use lots of different kinds of file types and upload them into the code interpreter. And I'll provide a link to the exact CSV file that I had, but it's super flexible. You don't need the one that I provided. You could use your own data or some other data set that you found. Then I just simply saved that CSV file to my local machine. And then once you've saved your file locally, there's a plus button where you can upload a file in the place that you would usually just send a message in the regular ChatGPT interface. There's now this extra plus button, so you can upload a file. And I just uploaded the Boston CSV file. And then the code interpreter says back to me, I see that you've uploaded a file named boston.csv. How can I assist you with it? And I was like, this is the Boston house price data set. Are you familiar with what the variables are in the file? And ChatGPT says back to me, yep, I'm familiar with the Boston housing data set. It's a commonly used data set. And then it gives me an overview of the 14 variables in the file. So it gives me the variable name that's in the data set and a one-sentence description of what each of those variables mean. And then it asks me, would you like a summary of the data or any specific analyses performed on it? So I kicked off this episode by saying I had 5 hacks for you. We've already actually done the first hack, which is data summarization. So just by uploading the file, it quickly realized what file we were looking at and summarized the key variables for me. The second hack that I have for you is an exploratory data analysis. So ChatGPT asked me, would you like a summary of the data or any specific analyses performed on it? And so let's start off just with a summary of the data. And so I'll say, yes, could you please do an EDA on the key variables? And for our listeners who aren't aware, an EDA is an exploratory data analysis. It says, and ChatGPT says back to me, of course, an exploratory data analysis involves understanding the data's main characteristics, often with visual methods. And so then it says, okay, let's focus on these 7 key variables in the Boston housing data set and follow these steps. Let's check for missing variables. Let's obtain summary stats. Let's visualize the distributions. Let's examine the relationships between variables, especially between the predictor variables and our target variable, which is the median value of the house prices. And so then it goes through these things step by step, and you can see the work. You can see the Python code that was created. So it starts off by checking for missing values and obtaining summary stats. And the first chunk of code that it creates and runs for me, and it runs right in the ChatGPT interpreter, which is super cool. You don't even have to copy this into your own Jupyter notebook or your local IDE or whatever. It'll just run right there in the instance. It runs into an error. So an error gets thrown, and it automatically figures out, without me having to do anything, the ChatGPT Code Interpreter says, it appears there was an error in accessing the specified columns from the dataset. This might suggest that the provided dataset does not have the traditional columns, or they might be named differently. And so it looks into it further, and it determines that, the problem is that the dataset that you uploaded, all of the variable names are in lowercase. And I was expecting them in uppercase. So it converts automatically. This is all happening. I haven't provided any prompts. It just keeps doing this. It just keeps running. It figures out the error, and then it converts everything to lowercase, provides you with the code for how it converted everything to lowercase. And then it does the work that it said it was going to do on that exploratory data analysis. So it looks for missing variables. It determines that there aren't any missing variables. And then it provides summary stats on the 7 key variables that it identified, not me. And so for each of those variables, it provides relevant stats, things like the median, the range of the data, the maximum, whatever the key summary stats were on those 7 key variables. It just suggested those to me automatically and did a really great job as far as I'm concerned. And then it goes on to create distributions of the 7 key variables. So it creates histograms for each of the 7 variables, which print out right there in the code interpreter so you can see them. And it then also provides a 1-sentence summary of each of those histogram plots for each of the 7 variables. And then it does a scatter plot between our target variable, the median house price, and the 6 key predictors that it identified for that median house price. So it creates these 6 scatter plots with correlation coefficients, and it provides a summary of each of those, another one or 2 sentence summary of each of these scatter plots, and the strength of the correlation between those predictor variables and our target variable, the median house price. And then at the end of all of that, so that whole time it's been running, all I did was ask it to do an exploratory data analysis. And it did all of the things that I've been describing since, like identifying what appropriate EDA steps are, encountering an error related to, not having lowercase variable names, and it was expecting lowercase variable names, fixing that error, and then running the code to, determine there are no missing values, calculate some summary statistics, create distributions of each of the key variables, and then create scatter plots with them as well. Really, really cool stuff. So at the end of all that, it says, these insights are a pretty good starting point for further modeling or analysis. Do you have any additional requests or questions about this data set? And so I said, excellent, thanks. Can you please process the data for a linear regression where we predict house price? And, one of the really cool things about this for me is that, I'm not even saying predict the specific variable name. So there's a specific variable name for the house price, MEDV. And I don't need to specify that. You can just use natural language. You could say, I want to predict house price. How should I pre-process the data? Or actually not how should I? Can you please? So that is now my 3rd hack for you. So the first hack was getting a summary of a data set. Hack 2 is doing an exploratory data analysis. And now hack 3 is this automated data pre-processing. So so it identifies great pre-processing steps for linear regression. it says we'll handle missing data, and we already identified that we don't have any missing values, so we can skip that step. We'll do feature scaling, we'll handle categorical data, we'll do feature selection, and then we'll split the data into a training and test set. And then it goes ahead and does those steps, or at least all the steps that are relevant, because it actually goes ahead and identifies, okay, some of these steps aren't relevant for this data set, so we'll skip those. And then it provides you with the code for how it does the scaling to standardize the data, and how it splits the data into a training set and a validation set. And it kind of explains some summaries on, okay, we got a training set now with 404 samples, a test set with 102 samples. There's 13 features in each of those data sets, and all the features have been standardized. Great. So then it says, you can now proceed with training a linear regression model on these preprocessed data. Would you like me to demonstrate that, or is there anything else you'd like to explore? And that brings me to our fourth hack, which is training machine learning models and evaluating them. So just doing machine learning or statistics, you can just do it right here in the ChatGPT Code Interpreter. So I said, fabulous. Now please train an appropriate regression model and validate the model using the test set. And just like everything else, it goes ahead and does it. It provides you with the code. It uses a linear regression model from the scikit-learn library in this case. And it then provides me with some sensible summary stats that are calculated on the test data. So it calculates the mean squared error and the R-squared score, and it explains what that R-squared score is to me in this particular instance. If you weren't familiar with mean squared error, which is something that we want to minimize, then you could ask for an explanation of that. But I know what a mean squared error is. It's just the cost that we want to minimize with our machine learning algorithm here. So I said, do you have any ideas for how we could get an even lower mean squared error? And so it writes back, certainly, improving the performance of a regression model in terms of reducing the mean squared error can be approached in multiple ways. Here are some strategies. And it comes up with a set of amazing strategies. So it comes up with a couple ideas for feature engineering. It comes up with 3 ideas for ways we can be regularizing the model. It suggests other kinds of modeling approaches, more advanced approaches than just a linear regression. So it suggests, you could do a random forest or gradient boosted trees, and it explains why it has these suggestions as well. So for everything that I've been saying, it explains why. So, for the random forest, it's saying like, a nonlinear model can capture more complex relationships than a linear regression could. It suggests support vector machines for the same reason. It suggests more data processing, like outlier removal and transformations that we could apply to the data. It suggests feature selection. It suggests ensembling, like stacking, bagging, or boosting. It suggests hyperparameter tuning, and just that we should be assessing our model assumptions, which is a really sensible thing to be doing here. So things like homoscedasticity and independence of errors, these are the key things that you need to be looking for. And so it's aware of all these. So in total, it has these 8 categories of ways that we can improve our machine learning model. And most of those categories are broken down into sub-bullets and lots of separate suggestions with explanations of those suggestions and why they might be helpful. So then it asks me, would you like to explore any of these strategies on the data set? And I just said, sure, whichever approaches you think would be best, please go for it. And so it says, all right, so let's implement a few of the strategies to potentially improve the performance. Let's do some feature engineering. We'll add some polynomial features to potentially capture nonlinear relationships. We'll do some regularization. We'll try both ridge and lasso regularization to see if that helps. And we'll try using a random forest instead of just doing a linear regression to see how that compares. We'll also do some hyperparameter. And then it also says, for now, we'll skip hyperparameter tuning. But in practice, that could be a good step as well. So then again, it writes all the code. It uses scikit-learn for all of these things, for the ridge regression, the lasso regression, creating the polynomial features, doing the random forest. And then it calculates the mean squared error results. So our previous mean squared error with the first approach that it suggested, or I guess that I suggested, the linear regression approach, that got a mean squared error of 24. And then after it did these, it ran these 4 other approaches. So a linear regression with, like the new polynomial feature that it had in, this improved the results. Our mean squared error went from 24 down to 14. That's a big jump. And then similarly, there were improvements with ridge regression and lasso regression relative to our baseline model. But the best results came from the random forest. And it has some observations on these. So it provides you with summaries of why our performance improved due to the polynomial features, due to the ridge regularization, the lasso regularization, and and it notes that the random forest had the best performance overall. And then it says at the end, so the random forest model has provided a significant improvement. However, further hyperparameter tuning, especially for the random forest model, could potentially lead to even better results. Would you like me to proceed with hyperparameter tuning? And so I said, yeah, please go ahead with the hyperparameter tuning, but just do it for the random forest model because it suggested that it could also potentially improve the lasso model with hyperparameter tuning. And I said, no, just, for simplicity, for the purpose of this demo, for this podcast episode, I was thinking, let's just do this as quickly as possible. Just go with the random forest model. So then it comes up with a great hyperparameter tuning approach. It suggests the specific random forest hyperparameters. There's a set of 5 of these hyperparameters that it suggests varying. And then it says, let's do a grid search with cross-validation. Very sensible choice here for figuring out what the best approach is. And then my code was running for a while in the code interpreter. And that's because there are a total of 1,080 different fits that it was going to need to do across this grid search that it had come together, that it had come up with. And so I was like, I wonder how long this is going to run for. I hadn't had a scene code run this long in the code interpreter before. And it maybe ran for 30 seconds or a minute or that kind of thing. And then it threw an error. And it understood exactly why it had the error. So it said, it seems the grid search took longer than anticipated and was automatically interrupted due to a timeout. To address this, we can take a few measures. We could reduce the search space. We could reduce the search space by selecting fewer hyperparameter values, or we could use a randomized approach. And then without me saying anything else, it just goes ahead and says, for the sake of time, I'll opt for the second approach and do a randomized search instead of a comprehensive grid search. This will give us a good idea about some potentially optimal hyperparameters without doing the full grid search. Let's proceed with this. Again, as always, it provides me with the code that it's using for that. Now we just have 250 fits to do instead of over 1,000. And so this still runs for a little while. Maybe it was like 15 or 20 seconds. And then it produced the results. So it said, this provided me with this set of hyperparameters that gave us the best results on the training data set. So then let's evaluate how this performs on the held out test data. And it finds that it gets a mean squared error on the test data of 10.5, which is actually slightly more than we had with a default of 10.2. But that doesn't surprise me because we didn't do a comprehensive grid search anyway. We rushed ahead because of the limitations in here of how long a process can run before being automatically interrupted, so that you're not using ChatGPT just as your, to be doing a lot of heavy lifting, training gigantic transformer architectures in here yourself. So you could, if you wanted to, you could take the comprehensive grid search code. You can copy it out very easily. There's a copy code button, so you can grab the Python code and put it right into whatever development environment you prefer yourself. And you could run that comprehensive grid search and maybe get better results. You could also just keep talking to this ChatGPT Code Interpreter instance and come up with other ideas for ways you could potentially improve performance and see how it goes. So we've gone through 4 of my hacks. So the first hack was just getting a summary of some file that you upload. My second hack was doing an exploratory data analysis. Hack 3 was data preprocessing. Hack 4 was actually doing machine learning. So we've been doing that for a while now. That's kind of been the meat of the episode. But one fifth and final tip for you is that the code interpreter is incredible for explaining code. So you can actually, that same file upload button that you can use to upload data to analyze, you can also use it to upload code or documents. And so, you could potentially upload a document and ask it questions about that document, and it will answer questions about the document. Or you can upload code and ask it to explain the code overall or particular aspects of the code, or adapt the code for some other purpose. In this case, in the interest of time of just doing something really quickly for this podcast episode, I simply asked for an explanation of this particular variable randomized search CV, which it imported from scikit-learn. And so I said, can you please explain all the arguments in the line of code where you called randomized search CV? And it says, of course. It's a powerful method for hyperparameter tuning, and understanding its arguments is key to using it effectively. Here's a breakdown of all the arguments used. So it lists out and enumerates all of the arguments, and for each of those arguments, it provides a few bullets explaining why you would choose that particular hyperparameter, or what that particular hyperparameter is for, as well as some example values that you might want to choose there, or values that you might want to change. So that's it. If you haven't used the code interpreter before, I hope that this episode blew your mind. The first time that I used this was completely stunned by what it can do. And knock yourself out. Use some data of your own and get going. Start making your life easier. There's no need to be struggling with your code or coming up with ideas for how you can be improving your machine learning models. Just have a conversation with the ChatGPT Code Interpreter. Have some fun. These hacks really do make being a data scientist more fun than ever before. All right, that's it for today. I'll be sure to have links to the data in the show notes. And in case you want to try to replicate more or less what I did here, there's probably some stochasticity in the model, so you're not going to get exactly the same answers or flow as I did, but you could get roughly the same thing. And yeah, check out the YouTube version if you're not watching that right now already, where you can see me walk through all of the code. All right, until next time, my friend, keep on rocking it out there. And I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.